All right, welcome back everyone. So we're talking today about how to map our joystick so that we get the motor speeds we need. To do that, we need to first understand what motor speeds we want when certain things happen. So if I move my joystick in the Y direction, I want the hovercraft to go forward. If I rotate to the right some, I obviously want to turn right. If I just go straight to the right without going forward or backwards, I want it to just pivot in place. So now we've got to think through each of those positions on our joystick. What does that mean for the motor speeds that we need to have? So as we go through this, I want you to open up your hovercraft notebook, find this page in there. It should be in the mapping joystick control section, and then follow along with me filling in everything. All right. So first thing we said is when we push the joystick in the Y direction here, we want the hovercraft to drive forward straight. To do that, we have to get both motors fired the same. So in this one up here, I'm going to say, okay, so the left motor has to be equal to the right motor, and they both need to be positive, which means they're both pushing forward. Awesome. So that's that one. And maybe the next easiest one to do is this one back down here somewhere. We can say, okay, here we want the same thing. We want the left and right motor to be always equal, but negative. So negative left motor is equal to the negative right motor. All right, so far so good. So anywhere along this axis, the motors are the same speed. They need to be the same speed, just forward here and backwards here. All right, so what if we wanted to make a pivot turn? Well, in that case, if we wanted to pivot to the right, we're going to need our left motor to push us forward while our right motor pulls us backwards. And that's going to give us that pivoting action. So here we're going to say that the left motor is positive because that's going to push the left side forward and that's going to turn us right. And it's going to be equal to the negative right motor. So in this case, equals here means equal in size. So if left motor is 100, right motor is 100, except the left motor is plus 100, the right motor is minus 100. So there, here it's it's a non-mathematical equals here. Okay, so then how about here? So we're going forward. We still want the left motor to be positive because we're still wanting to move forward. So we're going to say, okay, a positive left motor. And in order to turn, my left motor needs to be greater than my right motor, so it pushes harder and pushes the left side of the hovercraft forward some, which means we'll turn to the right. So I'm just going to say here that the left motor, positive left motor, has to be greater than the right motor. And here, I don't care actually if the right motor is going backwards a little bit or going forward some. As long as it's less than the left motor, it will start making that turn. All right, so far so good. Now let's jump over on the left side. So this is probably the easier one. It's going to be the opposite of this one. So instead of having the left motor pushing forward and the right motor pulling back, we're going to have the right motor pushing forward, the left motor pushing back, and that's going to rotate us to the left. So over here, I'm going to click in and say, okay, we need a negative left motor, a backwards left motor, and it's got to have the same size of value as the positive right motor. And by making these the same size of value means that they're going to pivot and not push forward or push backwards. It's going to just do a pivot for us. Now this one's the same way as before. So in this case, I want my right motor to be bigger and positive. So here I'm going to say the right motor is positive. And I'm going to keep the left motor on the left side, just keep everything balanced. And my left motor has to be less than. So the left motor is less than the right motor and the right motor is positive. Again, we don't care if the left motor is still forward some or if it's even going backwards. As long as it's less than the right motor, we're all good and it's going to make a turn. Now, the more different they are, the sharper the turn is. So when the joystick's up here, barely off to the left a little bit, there shouldn't be a very big difference between these two. When it's down over here and it's mostly to the left, there should be a huge difference between these two things. And we'll try and figure out a way to make that happen. So now as we go through with the programming, this is the motor combinations that we need to get. We need to get matching motors for forward, and then matching motors for negative. We need to make sure left is bigger than right, and that these two are opposite of each other on those far rights. So we'll keep that in mind as we move forward. Awesome job, keep going.